In the previous lessons, we have talked about equal and unequal expected frequencies. This video only covers contingency table analysis. It is important to have a background about unequal and equal expected frequencies for chi-square non-parametric methods. If you haven't checked that video yet, I will post a link in the description box below. To start, we have our definition of terms. A contingency table is used to investigate whether two traits or characteristics are related, meaning we want to know if two variables are related to each other. Each observation is classified according to two criteria. First, degrees of freedom. The formula is number of rows minus 1 times the number of columns minus 1. 2. We have to know our expected frequency. The formula is row total times the column total divided by the grand total. Chi-square can be used to test for a relationship between two nominal scaled variables, where one variable is independent of the other. To better understand this, let's try to solve a problem. Is there a relationship between the location of an accident and the gender of the person involved in the accident? A sample of 150 accidents reported to the police were classified by type and gender. At the 0.01 level of significance, can we conclude that gender and the location of the accident are related? So we want to know if the gender and location are related. So that's the purpose for contingency table analysis. To solve this problem, let's follow some steps. Step 1. We need to state the null and the alternative hypothesis. Our null hypothesis should be a negation of the statement, meaning we will use words or terms such as no, not, or never. In this case, our null hypothesis will be gender and location are not related. For all alternative hypotheses, gender and location are related. Number 2, or step 2, we need to have our significance level. In this case, it is already given 0.01. Step 3, select the test statistic. We will be using chi-square test with formula summation of the quantity of the observed frequency minus the expected frequency squared divided by the expected frequency. Now we need to have our observed and our expected frequencies to be able to solve this chi-square. First, we have our observed frequencies. It is given. For the gender, we have male and female. For male at work, we have 60 observed frequencies. For female at work, we have 20 observed frequencies. That would total 80 observed frequencies. For male at home, we have 20, female at home 30, and a total of 50. For male at other places, we have a frequency of 10. For female, 10, and that would total to 20. For the male gender, the total of accidents, we have 90. For female, we have 60. And the grand total would be 150. That is our observed frequencies. Now to solve for our expected frequency, just disregard this because this is just a pattern. Okay, we can try to read this. The expected frequency for the work-male intersection is computed as 90 times 80 divided by 150 equals 48. Similarly, you can compute the expected frequencies for other cells. So this one is the formula on how to compute the expected frequencies, and we will use that formula. But before that, let's proceed to step 4. We need to formulate our decision rule. The degrees of freedom is equals to row minus 1 times column minus 1. In this table, we have 2 rows and 3 columns, and that would give us a degrees of freedom of 2. And since our significance value is at 0.01, this degrees of freedom and significance level intersects at this point here at 9.21. So this is our critical value. This is how it looks like. Let's say this is our chi-square diagram. This is our bell shape. Sorry for my drawing. So this part here is our critical value. It is where 9.21 lies, okay? So if our chi-square value goes beyond that critical value, it belongs to this area. This is called the area of rejection, meaning we will reject our null hypothesis and we will acknowledge our alternative hypothesis. However, if our chi-square value is lower than our critical value, then it belongs to the area of do not reject, meaning we will not reject our null hypothesis. Instead, we will acknowledge it, okay? So to solve for our expected frequencies, the formula is row total times the column total divided by the grand total, okay? So let's start with male at work. Row total for male at work is 80 and the column total is 90 divided by the grand total, which is 150. And if we compute that, our expected frequency for male at work will be 48. For male at home, we have a row total of 50, column total of 90, and a grand total of 150. If we compute that, we will get 30. For male at other places, we have row total of 20, column total of 90, and grand total of 150. We will get 12. If we total this column here, it will solve as 90. For female at work, the row total will be 80. The column total would be 60. This one, 80 times 60, divided by our grand total, which is 150. And we will get 32 for our expected frequency. For female at home, column total is 60, row total is 50, grand total is 150. 50 times 60 divided by 150, we have 20. For female at other places, our row total is 20 times the column total, which is 60, divided by the grand total, which is 150. And we will get 8. If we total this column here, we will have 60. To total the work, we will get 80. 48 plus 32. And for home, 30 plus 20, 50. For other places, 12 plus 8 equals 20. Since we have a total here, we also need to sum it up. 90 plus 60 equals 150. This is our grand total. Next, we need to solve for our chi-square since we already have our observed values and our expected frequency. For male at work, the formula will be observed minus the expected frequency quantity squared divided by the expected frequency. For male at work, our observed frequency is 60 and our expected frequency is 48. Okay, so to solve for that, 60 minus 48 quantity squared divided by the expected frequency, which is 48. We will do the same thing for male at home. The observed frequency for male is 20 minus the expected frequency, which is 30, quantity squared, divided by the expected frequency, which is 30. For male at other places, the observed frequency is 10 minus the expected frequency, which is 12, quantity squared, divided by 12. If we total this column for male, you will get 6.667. For the female, we will do the same thing. For female at work, the observed frequency is 20. For the expected frequency, we have 32. Okay, so to solve for that, we have observed, which is 20 minus expected, 32, quantity squared divided by the expected, which is 32. We'll do the same thing for female at work. Observed frequency is 30 minus expected frequency, 20, quantity squared divided by 20. For female at other places, observed frequency is 12 minus expected frequency, 10, quantity squared divided by expected frequency, 10. Let's double check. I think we already got it right. Now if we total this female column, we will get 10. Since our chi-square formula has a summation in it, let's look at our chi-square test. There's a summation, meaning we will total the individual values or the individual total for each column. And we will have our grand total here. This is a summation, meaning this 16.667 will be our chi-square. Chi-square. Step 5. Compute the value of the chi-square statistic and make a decision. Since we already computed the value of our chi-square, which is 16.667, we need to make a decision. Looking back at our decision rule, let's draw again the bell shape. I'm sorry for my drawing. Wait, it doesn't stop anymore. I don't know what's going on. Erase the links. Okay, we will try to draw again. It's loading. Okay, so never mind the loading. I'm sorry. We will use our paint instead, okay? Because we have encountered a problem. Okay, so we need to remember that our chi-square was 16.667 and our critical value is at 9.21. So this is how it looks like. This part here is our critical value 9.21. If our chi-square value goes beyond our critical value, it belongs to the area of rejection, meaning we will reject our null hypothesis and acknowledge our alternative hypothesis. In this case, 16.667, it probably exists in this area here, 16.667. So we will reject our null hypothesis and acknowledge our alternative hypothesis, meaning there is a relationship. To conclude, let's write it down here. To conclude, there is a relationship between the gender and the location of the accident. There is a relationship between two variables. I'm sorry for my cozy handwriting. Between the gender and the location of the accident. Okay, so I hope you find this video helpful, and if this video is helpful for you, please give this a like and subscribe to my YouTube channel. Thank you.